Hi everyone, welcome to this new video lecture of fluid mechanics. In this lecture, we will discuss regarding Pascal's law. The Pascal's law states that the pressure or intensity of pressure is applied in a static liquid that will be directed in all directions equally. Or we can say the external static pressure which is applied in a confined liquid that will be distributed or transmitted evenly throughout the liquids in all directions. Let's consider a static liquid is there, and if you apply a pressure on any one point of a liquid, so that pressure will be applied throughout the all directions equal, okay, with equal intensity it will be applied. Now let's consider an example for this. Okay, suppose there is a container is there, and in this container liquids are present here. So in this liquid, we know that different shapes of liquids are there. So let's consider a liquid shape which is wedge shape is there. Okay, wedge shape like this kind of rectangle triangle shape is there, and let's consider this wedge shape of this liquid, and let's take it to outside. Let me draw it here. So this kind of shape of liquid we have considered. This thickness, let's consider this is a unit thickness is there, but how to represent this one? Let me tell you. This is the direction in this x direction, and this is y direction, and this is z direction, and the pressure applied on this surface, let's consider this is one pressure which is applied on this is another pressure which is applied on more surface, and this is one more pressure which is applied on more surface. So as per the statement, we need to prove that P equal to, we can say Px equal to Py and equal to Pz. That means the pressure which is applied in one point, that should be transmitted in all directions. So here we can see some examples I have taken. If we are pressing a point of, at one point of the ball, you can see how the pressures are released in all the points equally. Okay. Similarly, we can consider a hydraulic brake in which the brakes are applied at one point. Okay, the driver applying at one point at this paddle. So that same intensity of pressure is passing through this liquid which is present here, and it will be transmitted to all these tires or brakes equal pressure or equal intensity. Okay, that is called Pascal's law. So what pressure is applying here? The same intensity of pressure is applying all the directions, that we need to prove. Okay, so these are the pressures which is applied on all the four sides. Okay, and let me mark it here also. A, and this is B, and this is C, and this angle we can consider as a theta. Okay, any angle we can consider here or this one. Okay, now the pressure which is applied here, let's consider this is Py, and this is Px because it's in x direction, and this is Pz, that is z direction. Okay, so now let me give some name of these sides. At this surface, this AC side is there, so that is we can give dx, and this length is dy, and this side is ds. Okay, so these are the name of the sides. Okay, so now we need to find out, okay, what is the force acting on the element. What are the forces acting on this element? Forces acting in the element, this fluid element. Okay, so mostly first one force will be there, that is pressure force. That is pressure force which is normal to the surface. Normal to the surface, we can see this is one pressure, this is one pressure, this is one pressure. These are the pressures. Okay, we need to identify the pressure force. So second one is the weight of the liquid. Second one is the weight of the liquid, which is very negligible. but we need to consider that one. Okay, so the pressure force which is applying here, we know that the pressure equal to force by area. So if you calculate the force, then we can say pressure into area. So here area is, okay, let's consider one by one surface. Let's consider one surface is AC. So for AC surface, what is the force applied here? Now pressure applied on this one into area. So P y into area, we can write this is the length of this element into the thickness. Thickness is unit, we need to consider unit thickness. So that is dx into 1. Similarly, the AB surface, consider the AB surface, and here the pressure which is applied here, that is Px, and the length of this surface is, that is dy, and again the thickness, unit thickness we need to consider. Similarly, BC surface is there, and the pressure which is applied here, that is Pz, and what the surface here, that is ds into 1. So these are the pressure force which is applied on this, all the sides, all the surfaces, that is normal to this surface, you can say. So this is one term. Okay, now next is the weight of the fluid element. What I told you, we know that W equal to mg, weight of the fluid element equal to the mg, and we know that density of the fluid equal to mass by volume. So here we can write mass equal to rho into v, density into volume. So in place of m, we can give rho into v. Now volume equal to v equal to volume of the element. So volume we can write what? The area, what is the area of the fluid into what is the thickness of this. Okay, so that one we can write area into thickness or area into height, we can consider what is in this zone. So that one we can write. So area for this wave shape, for this right angle triangle, we need to identify the area. So that we know, let me write, this is rho into g. Area we can write, what the side is there, AB into AC, like in base into height, AC into AB divided by 2 into 1. Okay, the thickness is need to be considered as a 1. This is the W is there. Now these are the forces which is acting on this. Now see, here if you consider one pressure force which is acting perpendicular to this surface y-axis, we can see that is in horizontal condition. Vertical condition is there, this is horizontal condition is there. But one more pressure which is acting here, if you see, that is inclined to this object. So if I consider this pressure force which is acting on the surface, that is inclined given. So this, how much inclination is there? Let's consider this is theta, and this inclination I can resolve. This pressure force we need to resolve. So what is the pressure force here? Pz ds 1. So that is Pz ds 1. That is the force applying on this surface. So this force need to be resolved in two components, one x component, one y component. Okay, that is the concept. Now if I resolve the force in x component, suppose resolve the force in x direction, suppose x direction, then we need to consider how many forces are acting in the x direction. Okay, so x direction means we can see this is the direction is there, this one, and now this one you can see that pressure of the force is applying in this direction. Okay, so that means here the force into, we'll get here Pz cos theta, that means that force into cos theta. So force here Pz ds cos theta, so that is Pz ds 1 leave it now, cos theta will be there. Similarly here we can get Pz sin ds sin theta. Okay, y direction. So x direction, what are the other forces? Are that this is the x direction, that means Px dy. Okay, so write down Px dy into 1 leave it. Now this is in this forward direction, in this direction. Now this force which is acting here, that is negative direction, so we need to consider minus. So that is Pz ds cos theta equal to 0, because summation of force you can say is 0. Okay, now this one what we will do, Px dy equal to Pz ds cos theta. Okay, Now again we need to consider this right angle triangle. What is here? This is the right angle triangle is there, and let's write this is ABC, and this angle what we have taken theta. Now if you want to calculate the cos theta value here, so we can write cos theta equal to, that is your AB, that adjacent side divided by the hypotenuse, that is BC. Similarly, if you want to write sin theta, similarly what we can write, that is opposite side will be there, so AC and hypotenuse will be there, that is BC. Okay, very simple. Now if you want to write this cos theta value, how much will get here? So cos theta equal to AB by BC, and AB equal to BC cos theta. Let me write here. Okay, so we can write AB equal to BC cos theta. Now BC cos theta, once you see what is the value, BC equal to what? BC equal to DS. So we can write DS cos theta. Now AB equal to, what is the value of AB? That is dy. So we can write dy equal to ds cos theta. Okay. Now ds cos theta is here. So let's put the value over here, dy. So dy, if I keep here, then dy cancel. Okay. So what will get here? The px equal to pz. This is one equation. This is one equation. Okay. Another equation, that is, this is resolving the force in the x direction. Similarly, resolving the force, let's consider resolving the force in y direction. Okay, in y direction, how many forces are there? Let's see. So this is one force is there which is acting in y direction, that is py dx, this one py dx 1, and this pz ds which is acting here inclined, that component, resolving component we need to consider. This is one, and one more is there, weight of the element, though it is very negligible, so we will consider that one and we will neglect that. Okay, so weight of the element, fluid element also need to be considered, which is vertically downward, and this force also will be acting downward. Okay, so now how much this is? Py dx into 1 leave it, minus there you can see what is the value, pz and ds sin theta, minus this w value is there, weight of the element. So weight of the element, this total value we can write. Okay, or else we can write this w only equal to 0, because we know that again summation of force in the y direction equal to 0. Okay, now this w value, what are the terms are there, also we can write here rho g ab ac by 2. Okay, that also we can write, but let's keep it here like this. So we know that the fluid element is very, very small, so the weight of the fluid element need to be ignored, need to be cancelled here. So if you cancel this one, then what are the remaining terms will be there? That will be py dx minus pz ds sin theta. Okay, equal to 0. So equal to 0, that will be there. So let me do it equal here. So minus term will be there, this side will come. Now this ds sin theta, let's go to the here in this triangle. Now this sin theta, what we have written here, if I write this one, what I have written here, AC. So AC equal to, we can write BC sin theta. From this triangle, from this right angle triangle, we have already written here AC equal to BC sin theta. AC equal to what? AC equal to this one, this value, how much? Dx. So dx equal to, BC equal to what? Ds. So ds sin theta. So ds sin theta place I can keep dx. This value I can keep dx. So what will get here? Py dx equal to pz dx. Dx will be cancelled. So what will get here? Py equal to pz. This is one more equation. Previously we got one equation here, px equal to pz. So px equal to pz we got. Now see, py equal to pz, px equal to Pz. If you compare this equation, right, then you can write Px equal to Py equal to Pz, which is the statement given by the Pascals. That means the pressure which is applied at one point of the static liquid, so that will be directed in all the directions equally. Okay, so this is all about the derivations of Pascal's law. I hope you understood how to derive this Pascal's law. If you are having any kind of problem or query on this, you can give a comment on the comment box. Thank you all.